My name is Sumeet, and I am currently working as a data scientist at Cognizant. I have around 6 years of experience into data science and software engineering and into Python. And I'm working in the banking and financial sector domain. And previously, I have worked in industrial automation and healthcare domain. And my hobbies are reading books, watching movies, web series, and you can connect with me on the LinkedIn, Medium, and email social handles. The links are provided. So coming to the agenda, first we will discuss about collecting and pre-processing the English and Hindi text. So this will be a open source corpus from Gutenberg for the English, and for Hindi we would be getting the Hindi novels and articles from the GitHub. So that is downloaded on the local. I will show that once we begin the session. And then we would be applying factorization, inverse document frequency, and SVD to get our word vectors. And then we will generate n-gram vectors of various dimensions. So that would be the hyperparameters we will discuss further. And the second part of it would be to generate a bot text. And then we would use LSTM character level generation to generate the English Hindi bot text. And when we have generated that, we would pass it to the same pre-processing pipeline discussed in the first point to generate the word vectors. And that would then be clustered using HDB scan with a hyperparameter tuning setup. And after getting the clusters, we would compute some metrics and then perform statistical hypothesis test. So this is the brief actually what we will follow in this session, and then we will conclude our experiments and the floor will be open for question answers. So coming to collecting and pre-processing English and Hindi text. So first we will cover the English text. So we would be using Gutenberg API to collect English literature novels. So this is actually a practical session. So I will open the Jupyter notebook side by side. So we would be using NLTK and Spacey to do our pre-processing. So we would install the tokenizer, stop words, and WordNet for the lemmatization. So first we have initialized all of this. And then actually there is a good index web API from that we can pass the relevant parameters to get the English novels. So we can pass the author here start, author here end, and we will get the indices of the books which we are looking. So then we will append those URLs, and then we will use wget to install those book IDs. So I had already done actually, so I will show it in the local how it looks. So here is the example of one of the books. So we will have the title and the text. And for some of the books, we have some header information which is not required, the volumes and all. So for that, actually, we will do some pre-processing. So we would use a Gutenberg cleaner Python library to clean those irrelevant headers, volumes and all. We only require the text and the title, chapter names. And then we will write it in a separate folder, and then these files will be used further. So we would be selecting 10,000 of those, and then let us go to that pre-processing pipeline. Yeah, we will first substitute all the phrases like we have the won't, it will be, will not, cannot, am not, and will, would, all that we will change, and some regular expressions to clean the text, the special characters which are not required. And then we will capitalize the first letter of the sentence. Here actually we will use NLP to first we will create a POS dictionary so that like we can uh, substitute the name of the person like John to a proper noun, and he or she will be pronouns. So this will be the part of speech tagging which we would use further. And first we will uh, substitute the phrase would not and all to, we would pass the book text, and then we will also have the named entity recognition. So for different money, country, or anything, it will be tagged into a one common name. And for identifying those, we would label it with _1, so that when we are removing the stop words and all, we would ignore those and would not substitute anything for them. So here actually we are checking if the word is out of vocabulary and all, then we won't include in the clean text file. So these are some of the pre-processing which we have done, and this will be passed into a multiprocessor worker function. So we would be applying multiprocessing as this is quite compute intensive, and to reduce the overhead, we would be initializing it with like 4 workers. So first, this one is for getting the bot text. We will cover this in the later sections. Here actually we are initializing the multiprocessing, like we will be using pool and map to do that. And files, we have the files list, and it would be a generator. And we are getting the CPU count using multiprocessing.cpu count. This will run this pre-processing function which we had defined, MP worker. And the input will be a list. And then we would be creating a corpus for this file. And we would append all the cleaned elements which we had done previously into a single output file that would be named as English corpus.txt. So now this we have covered for English language. Mayank has posted a question. What do you mean by putting the 4 worker functions? So Mayank, basically we would be utilizing the CPU cores, like we have 2 core, sometimes 4 cores. So we, based on the number of cores in our system, we would be distributing the function so that it runs on different cores. Like we can parallelly process this MP worker function on 4 cores, or like if 2 cores are there, we would this function would execute on 2 cores simultaneously, so that the operation is performed in minimum time. And this is actually compute intensive operation, as we are using certain NLP pre-processing steps. I hope it answered the question. So we would go to the Hindi pre-processing pipeline, how we would generate the clean text. So here actually we would be using John Snow Spark NLP. It has pre-trained pipeline for the lemmatization tokenization. So it involves a bit of Spark knowledge in it. Like we would be using PySpark, and then we would be setting up the document assembler, and we would be setting up the tokenizer. Then we would be using the Hindi pre-trained lemmatizer. And after that, there would be a finisher stage where we would be getting the pre-processed text that would be kept into the Hindi corpus. So first we would be reading the Hindi stop words. Actually, this process is a bit of manual. We would be then removing those stop words. Here we are getting the Hindi pause tags. So there is a pre-trained TNT pause tagger, which we would be using for getting the pause tags, and that would be applied on our Hindi corpus. So here we have created the get lemmatizer function, where we would be doing the pre-processing as we did for the English. And here we would be creating the NLP Spark pipeline. And then we would be selecting the final column as finished lemma, which would be the final process text. And that we would write in a separate file. So this would be done for all the Hindi files. So yeah, for Hindi, actually, we have generated the files in this manner. So coming to the English one. Now we are good to go with the next step. Like we can apply TF-IDF and SVD to generate the word vectors. So first we would perform TF-IDF vectorization on the processed files. So here actually we are giving the English corpus file in the TF-IDF function, and here we are setting the analyzer as word because we need the word vectors, and we can set the minimum DF as 3 or 5. So how much frequency we want for the words, and if we want to use the inverse document frequency or not, and what should be the token pattern. So token pattern, we are using the word pattern only, digits and all we are ignoring. And then this vectorizer will be fit and transformed on our training corpus file, and then we will get the vectors, the inverse document frequency vectors, and the English dictionary. So this method we will pass to the English corpus text and set up the relevant parameters to get our English vectorizers dictionary. So in the end, actually, we are writing all these words in the English corpus dictionary. So the English data vectorized, which we obtained from the above steps, we would be applying SVD on it. So yeah, let's go to the SVD side. Actually, we have to do a low rank K approximation of the matrix. So for that, we have to select the value of K. So value of K can be either a hyperparameter or it can be chosen mathematically using Acadian theorem. The next slide will explain that. So these are the basic mathematical definition of SVD. We would be decomposing it into the left singular and right singular vector with the singular vector matrix. And we have to select a dimension K such that the matrix AK will approximate A, and it would minimize that objective function A minus AK to norm. So for that, actually, K can be computed using Acadian theorem. The details are listed on the next slide. So Acadian theorem states that the 2 norm of the A minus AK is equal to the singular value of K plus 1 for the A matrix. And 2 norm of the matrix can be computed using square root of max eigenvalue transpose of A and A product. And here actually sigma and uh, the eigenvalue will be represented by lambda. And with this, actually, we can approximate the value of K. So this K actually we have computed using this approach. So it was 10. So for our data, it came out to be 10. So we are then decomposing the English vectors into U sigma and the VT matrix. And now actually we would be getting the row subspace of the matrix to get the word vectors as the columns. So we have to compute the row subspace of this matrix A. So row subspace of this matrix A will be sigma V transpose, and for A transpose it would be U sigma. So in this example, actually we have taken the transpose of this. So we will have U sigma as the row subspace to represent the whole word vectors in the space. So this thing will be stored in a NumPy file. Mayank has put a question, how you got to know about this particular theorem will help in your use case. So Mayank, this is a very popular approach used for low rank K approximation. So previously people had developed some heuristics to get the value of K by approximating it with the sigma value on the diagonal of the matrix. But this one is a more concentrated theoretically, and it can be proved also like by mathematical induction. At the end of the session, I will share you the links on this. So now we have the English vectors with the reduced dimension, and we have English corpus dictionary. And so here actually we would try to generate the vectors and store it in a file. So here we would be using the binary search to get the English vectors, and those vectors will be stored in a dictionary for faster use. And also if the word is already present, we don't have to search again. So we would be doing some stripping and all for pre-processing, and then we would be appending it to the file and also to the dictionary, and that thing will be returned, will be the return value of the function. So basically we would be searching the word in the dictionary and getting the corresponding vectors. So if that word is not in the dictionary, then we won't get the vector. So we have got the vector dictionary. So here, as you can see, speak word can be represented as a dimension with column dimension as 10, which we had specified for the SVD. Similarly, some other words are also there. So we have got the word vectors, and we will proceed to the next step of generating the n-grams. So for n-grams, actually, NLTK offers a n-gram support function. So here we can specify the n-grams function, and the text which we have, we can split it into a list, and the n-gram we can give whether it is 1, 2, or 3. So this one is basically the simplest of the method which is used for getting the word vectors. There are many word2vec and all, but we would be proceeding simple in this approach, like we would be using n-grams. So for generating the n-gram vectors, we have a helper function. And here actually we would be giving the range of n-grams. And for dimensions also you can make first, but we have computed it as 10, but we can do it for a range of 4 to 10. So for that I have specified the value of m. So first we will generate the n-grams, and then for generating the n-gram vectors, I would be concatenating it, and those things will be stored in a separate numpy array. So concatenating it will make it to 2D, which has to be reduced to 1D, and then this array will be saved in numpy gz file. So yeah, this is the preprocessing and the creation of word vector, n-gram word vectors for English. So similar thing can be followed for Hindi also. So for Hindi also we can use TF-IDF and apply SVD, and then generate the word vectors and get the corresponding Hindi vector dictionary. So yeah, this is still the generation of n-gram vectors for the human text. So we can go across to the generation of English bot text. Similar thing will apply for Hindi bot text. So coming to the bot text generation, for this, first we have to create the English vocabulary from the corpus. So for that, actually, we would be using the corpus, and then we will be getting the characters to index array and index to characters array to get the list of unique characters which are there in our English corpus. So as this is a character level, it will predict the next character in the sequence. And then we can set the sequence length. So here we have set it to 256, and batch size we have selected as 16 to pass to the model the certain length of sequences with the in a batch, and it will be used to train the character level LSTM. So this is the evaluation of the model. We would have the prediction length to be 200 by default, or we can have anything 500 also, but in our use case we can do for 200. And temperature parameter will control the randomness of the predictions by our model. So if the temperature is less, then the prediction will be less random and more accurate. If it is more, then it will be more random. And this would run in a loop, like we would get the predicted text, and that thing will be used to generate another text, for the next character. And coming to the model, it is a simple model. Like we have the encoder layer, and which would be an embedding of the input size and embedding size. And we will have the LSTM, which has the embedding size, the hidden size. These all are hyperparameters which we can set up when we are training the LSTM, this model. And we would have a dropout of 0.2. So this is to prevent the overfitting of the model. And the final layer will be a linear, fully controlled layer, and that will emit the input size, and it has the input hidden size because we are outputting hidden size from the LSTM. And here we have just initialized the layers. Here the layers would come into action in the forward method, and we have to do some squeeze and unsqueeze because we have to compress some dimensions, and we have to elongate the dimensions based on the input sequence which we are giving to the network. And in the last thing, we will initialize the hidden layer. So hidden layer will be a vector of 0, 0, and the dimensions will be batch size, hidden size, and the number of layers. And this will require the gradient computations during training. So we have put requires gradient is equal to true. And we will be moving it to a device that can be like CPU or a GPU. So we are using torch.to device. And here we are checking the device if we have GPU available or not. Then we are initializing our character level RNN with the required hyperparameters. Then we would be selecting a random line. Here we had selected first line from the human corpus. That would be the input sequence for getting the predicted sequence from our character level LST. Yeah, Athira, you had a question. Yeah, Athira, we can use Keras also, Keras TensorFlow also for getting the character level LSTM. Any framework which you are comfortable, we can uh, have this model architecture and generate a sequence. Like it is used popularly in stories generation or any such fake news or fake text generation. Yeah, Athira, we can discuss it offline. Actually, there are some more sections to be covered. You can contact me on my mail. So now we would create the training procedure. We would uh, initialize our criterion. It is the cross entropy loss, as we would be passing a vector of the indexes of the characters. So that can be treated as a label encoding. So we would be using the cross entropy loss for the model, and optimizer we would be using Adam, and we would set up the learning rate. The initial learning rate would be 0.01, and we would be setting up a learning rate schedule. So it will reduce the learning rate if the model is overfitting. So that is handled by the torch while we are training the model. And for that, actually, we have to set some parameters. Number of epochs we have chosen as 10,000. We will train the model, and then we will get the predicted output from the model, and then calculate the loss, and we would calculate the backward gradient, and then we will set it up to 0 gradient because we have to uh, do the evaluation. So here we would print the logs of what we have trained, and we will get the predicted text when we have the loss average of certain length. That time only we will print this sequence. So this will take some time, and when we can save the model checkpoint also, so that we can resume the training from that point. And after the model has been trained, we can pass it into the evaluate function, which I had shown in the previous steps. So we would use both the character to index dictionary and index to character dictionary to get our predicted text. And start text will be either a first line of the English corpus, or it can be any random line. And prediction length also can be set up by default to 200, or we can setup based on the file name character. So we had used this heuristic to get the prediction length. Then we would save all this input into a file. So this same pipeline is used for the Hindi also. Same pipeline for the Hindi also, just the encoding will be UTF-8 for Hindi because we don't have the Latin encodings and all for the Hindi. So after generating this BUT files, we have to pass it to the same pre-processing steps and generation of n-gram vectors. So we would use the same approach which we did for the human corpus for English and Hindi. So coming to the next step of clustering those word vectors. So coming to the clustering, actually, we can use k-means also or any density-based clustering method. But the reason I chose the density-based clustering because it can identify any shape of the clusters, and also we won't be restricted to convex shaped clusters. We can get any type of clusters and any shape of clusters, and also like if we have noise and outlier points, we can segregate them easily. So here actually we are setting up the rapid Cuda libraries because HDB scan, if we use from the scikit-learn, it won't be able to perform heavy compute operations since we have selected text which has the dimensions ranging to millions. So we will get out of memory exceptions if we will handle it on CPU. So we would be using the GPU. So it would check like if we have GPU on our environment, and it will set some environment variables for the CUDA. And here we can install our HDB scan. And for hyperparameter tuning, we would be using Optuna. It's a type of Bayesian optimization technique where we can use a TP sampler, and also we can use grid samplers and random samplers also. But here we would be proceeding with Bayesian one because it is faster than both of them. And the metric on which we will tune the parameters will be Silhouette score. So Silhouette score is basically the division of the mean intra-cluster distance and divided by the mean inter-cluster distance. So we have our objective function where we would maximize on the Silhouette score, and the parameters we have cluster selection, Epsilon, and actually cluster selection method for HDB scan in CUDA currently supports EOM, excess of mass, but we have another also. So that can also be a hyperparameter, but in this case, we have not considered because of that limitation. So we would be generating clusters based on the hyperparameters we obtain from this experiment. So we have this get best params method. So we would be doing it for human text corpus as well as bot text corpus. So we have some limitations which we have written in this notebook. And then we would be performing the HDB scan on the best hyperparameters obtained from the above. And then after we have done the clustering procedure, then we would be getting the word vectors which are there in these clusters. So we will get the clusters from this method. And once we have got the word vectors for the human and bot text, we would be computing some cluster metrics, which would be later used in the hypothesis experiment. So one of the metrics will be computing average distance in a cluster. So this one will be getting the distance and dividing it with the number of combinations. Like we have the how many pairs we can select from the cluster. So we would do this, and we would use p distance. So this one is a optimized computation for the pairwise distance for a given matrix X. Then we would append those average distance of the cluster, and another metric will be counting the unique vectors in the cluster. So that also we would store in a list. So this we would do for the human corpus as well as bot corpus. We observe that there are many ones and zeros in our metric in the count unique and average distance metrics list. So that we would remove it because it will give a more skewed distribution, and our hypothesis testing would not give proper results as it would get biased towards those things, and that's why we would be trimming it out. So after getting the cluster metrics list, we would be performing certain non-parametric hypothesis testing. The reason for selecting non-parametric hypothesis testing is like we don't know the distribution of those cluster metrics, like, and we can't estimate the parameters, whether it is what is the mean and the variance of it. And also the sample size is quite small. So we would be doing the non-parametric hypothesis testing. So for that, actually, we have samples of unequal size. So we would be using, and also the distributions are independent of each other, as human and bot text are, we can't have a dependency in between them. So we would be using Mann-Whitney U test. So our null hypothesis will be if the English and Hindi human and bot text, they are coming from this same population or not. And alternate will be they belong to a different population. And we would be selecting a significance level alpha equal to 0.05. It is the default value. And we would be running the statistical test for the two cluster metric lists, which we obtained above, and computing the p-value. And if the p-value is less than the significance level, then our results will be statistically significant, and we can reject a null hypothesis in the favor of alternate hypothesis for the sample which we have considered. So before performing this test, we would remove the noise labels, as that would lead to bias in our hypothesis test. We have to run it on true cluster metrics only. So we would be then applying Mann-Whitney U test that is available in SciPy stats library. So same thing we will do for Hindi also. Then we will obtain the results. We will see that p-value is coming less than 0.05 for our given sample. So our results of the experiment are statistically significant. So we can say with a certain confidence that we can reject the null hypothesis in the favor that both the human and bot text are coming from a different distribution. So yeah, we can conclude it in that way. And also, like, we can mix the human and bot text and then perform the statistical hypothesis test to check our results. And on that basis, we can mix and match also and see like how the results vary and if they are still statistically significant. So that can be the next steps in this exercise. Yeah, from my side, that is all actually. The floor is open for questions now.
Entering the question and answer session, guys, do fill up the poll I just launched. and then you can ask any questions and answers. So Sumit will be happy to answer. Sumit, Athira has asked a question in the chat box. Can you please answer?
Yeah, like why do we use AI for NLP? So, Athira, both are linked actually. Like uh, we we need the AI principles also for NLP as they go hand in hand. Like we are doing some pre-processing and we are doing it on some heuristics. So that heuristics are decided by the AI, and it is quite beneficial in generating the pipelines and also for the understanding of the models which we have created. Yeah, Atira, hope I've answered your question. Or you, if any additional details, you can ping here.
Do you have any more questions?
Uh, PyTorch or Keras are deep learning frameworks which help us in building the neural networks. Yeah, we can build it from scratch, but uh, they have all the inbuilt functionalities for the architectures and the layers, and all the back propagation and gradient computations are incorporated in those frameworks only. If we are doing from scratch, then we have to write it separately. And they have the reusable APIs for creation of the deep learning networks. So we are using those frameworks. Thank you,